So now I'd like to quickly jump into Mapping Manager to illustrate what exactly happens. So let's open up a particular use case right here. Let's go back to Lineage and let's open up M customers. So M customers, as you can see right here, is a combination of staging customers and M orders. So again, just two tables instead of the three that we have seen. But again, all of these columns have associations similar to what we have done. So what do? Well, I open up the Mapping Manager. Here I've already defined the source and target and the mapping steps. So I'll just walk them through again. We've defined our sources from our multiple systems. We have picked up our target. Then I have defined the transformation logic here. In this case, I have done this manually, but you can upload a mapping Excel to do this. You can connect to Calibra, you can connect to Catalog, Purview, and a lot of other tool sets. Wherever you have this logic, we can connect to it. And as part of our upcoming release, what we are planning to give out is a utility that converts your notebooks into this particular format of mapping and lineage. That really is going to help with use cases where documentation is sparse, which unfortunately for our industry is most of the data projects that people work on. So main use case here is that, well, this transformation logic can be created. And even if we use a script, we will create this in plain text. And the main reason for that is that the code itself could be incorrect. So it could be biased as well. So if there is some issue in that, for deployment, it's very important for an end user to come in and make sure that this is exactly what we're expecting. That first order that should just be the earliest date when a customer placed an order. And the reason this is important is going to come in handy when we create transformation checks in an automated way. And let's pick up one of those test cases that were automatically generated. So it was the same process that I've done, except it was completely automated. So here we have applied the transformation in our same M orders. We're comparing that against M customers. And when we do this mismatch, here we see that the transformation logic is disproportionately incorrect. Basically, what we believe this use case refers to is the developer adding a couple of extra flags, other conditions to distinguish between what the latest order date and the oldest order date is. So these numbers are highly inaccurate for a substantial chunk, meaning that there's some logic that has been applied, which is not from the expected realm. And so in this way, test cases can be generated for all the columns. Yes, you can combine them as well. We do club them together so that it's easier to work with. As if you do not do this, if you do not club your test cases together, well, the application can map them all together. There's no limitation there. In fact, you can even ask it to map it together. But it kind of it kind of skews your use cases into really difficult queries. As you can see in this example, we are doing a lot. We are doing transformations. We are using windowing functions. We are doing a lot of joins as well. This is to illustrate that the application can work with highly complex transformations as long as the correct context is provided. And so that is our use case with ETL validation. We supply this particular data model, we provide some information, and we let the application handle most of the systems. Of course, you have a lot of control when you create these test cases as well. But the key aspect is that most of it is automated, and thus it can also be, say, updated. Your description changes, the test case can also change in an automated fashion. So that's ETL validation in a nutshell.
For further questions, feel free to reach contact@datagaps.com. Request a free demo. Scan the QR code below. Thank you.